And I'm Katerina Barone Adesi, and I want to talk about why we need open systems and how to create them in the time of the cloud. So this talk will be a little more philosophical, and you might want to have some paper in case you have an idea, because I'll be asking lots of questions. First, a little bit of background, who I am and what I'm doing. So, I work at an open source consultancy named Igalia, and I'm on the compilers and networking team there. We've been using some software called Snabb. You can see it up in the corner in tiny letters. And I'll be talking a lot about Snabb in this, and specifically about lessons I think that we can generalize from Snabb to other projects. And my team has been using Snabb for IPv6 transition tools. Specifically, there weren't any fast open source implementations of something called Lightweight 4/6, which is a variation of DS Lite. And specifically a part of that called Lightweight Afters. So my team went and built one. And we managed to do this relatively quickly with quite a small team. And so I want to talk about why Snabb lets small teams do things like that, and how we can have other systems provide the same types of capabilities to different teams. So, what do you think the next 10 years of cloud computing should look like? Any takers? Anyone?
Everything outsourced to Amazon, Google, Rackspace for that.
Well, that's one option. And there's a place for it, but I hope that's not the whole future of cloud computing, because that would be a little bit sad. And I want to think about things like what the benefits of open systems are, because the systems that you mentioned are notoriously not all that open, although they have some open components. And so I'll be referring several times to an open cloud tool, Snabb, which, by the way, can be part of OpenStack with Neutron and stuff. So the previous presentation actually has a lot to do with this one as well, in a way. Alan Kay said, I think in the 1970s, the best way to predict the future is to invent it. And I think this is probably our best chance of predicting what the cloud will be like in the next 10 years. Because if we don't invent it, we probably can't predict it either. So, then I think the question is, what will help us invent it? Right now, the cloud is leading us, as the audience commented, towards centralization and a handful of large providers. And as we saw in the previous presentation, this isn't inevitable. We already have tools like OpenStack, and we have a variety of things that we can use to decentralize the cloud while retaining its benefits. We can choose to build open infrastructure. Open infrastructure has been important for decades already, and that's something that is not changing with the cloud, even if some of the technologies involved do. It gives you vendor independence, which, if you're dependent on Amazon or Google, you don't really have. And it gives you the freedom to make new things without having to wait for large providers or convince them. I've never managed to convince Google to do anything. Maybe some of you have. And it gives us the power to create infrastructure, not just consume it, and not just build on it, and not just providing whatever some other company decides is a good idea. And, of course, running our own clouds gives us more options in terms of data protection. I've covered a bit of this already, but there's the question of, can we have open infrastructure in the cloud? And as most of the other talks today have shown, I think the answer to that is a clear yes. We can provision things on demand and have this flexibility while also having open infrastructure. People have talked about OpenStack, they've talked about Puppet, they've talked about Ansible, they've talked about quite a number of technologies. So the question then is, what do we want this combination to look like, and how can we improve on the current state of it? Enough philosophy. So, as I mentioned, I've been working with some software called Snabb, and I'm going to discuss some of its design principles and some of its ideas. And hopefully, they'll give all of you some ideas of how we can make our infrastructure more understandable, more composable, more accessible to small teams, and more flexible, as well as open. What is Snabb? Essentially, it's a toolkit for writing networking software that runs at line speed on 10 gigabit NICs. So, it's a bit specialist, and there are several things in this field like DPDK and so forth, but it's useful. And probably not everyone in this room needs exactly that, but I think it's still a very rich source of ideas. And there's the question of, why does my team and why do other teams use Snabb? And essentially because it's the kind of tool that lets individuals and small teams invent the future. Not just large companies, not just hardware companies, not just the cloud providers that we can name offhand. But it lets us build and modify our own infrastructure rather than just building on the infrastructure that's given to us. And hopefully this sounds familiar because these are some of the ideas I was talking about in the philosophical part of this talk. Then there's the question of why Snabb and why open systems in general. And the reasons for that are the same as they've been since at least the 1970s. Flexibility, vendor independence. It's under an open source license in the case of Snabb, the APL v2. And these are all important, but they don't differentiate tools like Snabb from tools like OpenStack. So, what's interesting about Snabb specifically that makes it worth studying? One thing about it that's nice is that there are no proprietary dependencies. It's also relatively hardware independent. You can use it with network interface controllers from different vendors. And more interestingly yet, it has a community of developers and consultants, not just one company. So when you have an ecosystem like this, you can go to anyone within that community and have them develop custom software or get the expertise in-house and do it yourself. And this is pretty powerful. It'd be nice to have the cloud look more like this. Now, more into what differentiates tools like Snabb. It's what I would call an empowering tool. It's a small system that lets individuals and small teams do rapid development. It's not like the kind of system that we were hearing about in the previous talk where it takes 120 days to provision a VM. It's exactly the opposite of that. I want to talk a little bit more about the idea of a small system, because because I think that's one that's falling by the wayside a little bit, and I think it's important to bring it back. In the case of Snabb, it originally had a code budget, and the original idea was to keep it within 10,000 lines of code, have compilation take less than 1 second, and have reproduced executable fit on a floppy. In practice, the system has gotten a bit bigger than that by now, but when you start with a system that small, the whole system can fit in one individual's head. And this allows you to have a much more cohesive and extendable system than you have otherwise. You see this with classical Unix philosophy as well. You have a lot of small tools that do one or a handful of related things and do them well. You don't just have a gigantic amorphous blob that implements the same thing 7 times in 7 different incompatible ways. And this is a huge win for maintenance and for being able to extend and rapidly develop a system. And so as I was just saying, if you have small, well-defined concepts and you have a comprehensible system that developers and deployers understand, you can do things very quickly. If you look at Snabb itself, it's very fast and powerful. It gives you 10 gigabit user space networking that, until relatively recently, was a relatively arcane and niche thing to have. And it gives you this in a high-level language at that. And it's a contemporary example of how small and production-ready software can coexist. It's not a toy small system, it's one that you can use in production at speeds that most networking software can't achieve. These types of systems give users, small groups, and companies more flexibility and more autonomy. Like what was discussed in the previous talk with businesses, sometimes you really want more flexibility. And when you have these types of small systems, you can have that. You can expand what individuals can quickly build, and this is important because the more people you get involved in a project, the more communication overhead you have, the more politics you have, and the smaller of a team you can build something with, the less these are factors. In the case of Snabb, it lets individuals build line speed, user space networking tools. But what else would it be useful to build faster? I'll let you guys think about that for a minute. With the cloud, technology is changing. We have different buzzwords, we have different architectures, but we have to keep in mind the lessons from the history of computing, because a lot of the systems are the same. A lot of the design concepts are the same, and those who forget the past are doomed to repeat it. The best way to predict the future is to invent it, just like it was in the 1970s. Vendor independence and open systems are still essential, just like they were in the 1980s with Unix, just like they were in the 1990s with Unix, just like they are now. Small, comprehensible systems have a long history, and even when they haven't had a direct impact, they've generally ended up influencing lots and lots of other systems. You've heard of things like just-in-time compilation. It was first implemented in Smalltalk, which was another small comprehensible system. And generally, small comprehensible systems end up being decades ahead of the mainstream of computing in the areas where they specialize. They're worth taking ideas from. So I think that all of these concepts are important for the future of cloud computing. What does your team wish that it had that it doesn't have now? Can you think of a small comprehensible tool that might help you build it? And if you can build it, will you go ahead and do that and share it and document it so that we can have an ecosystem of these tools? Cloud computing is taking off right now. And the question is, who defines the future of cloud computing? Do we want it to be a handful of big providers? Or do we want it to be the people in this room? If we don't build the tools, the people that will build the tools will define it. If we choose to invent it, who knows what will happen? We'll have as good of an idea as anyone else will, at least. So, let's imagine a future where our tooling is like Snabb, comprehensible by individual human beings, modular, rapid to develop with, vendor independent, and open source. A future where our teams can have the tools they want and need quickly. Does anyone have any questions or comments?
Well, hi, I have a couple of questions. So the first one would be, what about, performances, for instance? So does it do kernel bypass on all drivers, or how do you cope with that?
Yes, Snabb in particular does kernel bypass, so it has drivers for a handful of networking cards from Intel and Solarflare and so forth.
What for those that you don't support? It's just simulation or just...
Sorry, what?
What for those that are not bypassed at kernel level? So
you could use untapped devices in theory, but in practice that's way too slow to be worthwhile. Essentially the idea with Snabb is to be small and minimal and not support every piece of hardware under the sun.
Okay, got it. Thank you. The last one would be, what about performance testing? So what's your data when it comes to performance testing? What would you suggest to start playing with it? I've got kind of exposed to Packet Blaster or something like that to replay the traffic. Is there anything better or?
This is an area that the Snabb community is actively exploring at the second, I'd say. In terms of the upstream Snabb project, I believe they're doing more and more work with the automated continuous integration system, also doing performance testing, so they automatically notice regressions. With the project my team has been working on, we've built various bits of benchmarking software so that we know how quickly we're processing different types of packets. And as a community, there's also been a lot of recent work on improving the profiling tools. So it's basically a multifaceted thing.
Got it. What's the difference between the branch, the upstream one, and the Igalia branch, if anything, or the fork or the branch?
Okay, basically the Igalia fork is where we're developing the lightweight after. So hopefully we'll merge at least part of that upstream. We're working on things I mean, we'll need to refactor our ICP and fragmentation handling and so forth, but we definitely want to upstream those. And as for the rest of it, it partly depends on how the philosophy of including things versus maintaining them in extra branches go.
Okay, got it. Thank you very much.
Yeah, gladly.
Some questions? My turn. I like a lot the philosophical view. Okay. It remembers me Unix, and I like Unix and old style net, so it's I love it. But can you share maybe some use case, use example of Snabb switch or this kind of thing? Because the philosophical point of view is of course excellent, but maybe for some people, for me too, it's interesting to have also some real use case.
Yeah, well, the real use case is what I do professionally for a living. My team has spent the last 3 months developing a lightweight after, which, like I said, is an IPv6 transition mechanism. And the real use case is that Snabb lets individuals and small teams develop the tools that they want to have and don't. More than a year ago, I believe, a guy at Switch, the Swiss academic network, named Alexander Gall, did some layer 2 VPN stuff that he wanted as well. And basically the point of Snabb is that if you want a high-speed networking tool, as in something that can run at line speed on a 10 gigabit card, and you're an individual and that tool just isn't there, you build it. Or you contract with someone to build it.
Okay, yeah, I get it.
And aside from the philosophy of Unix, the main developer of Snabb, Luke Corey, also brought in a lot of ideas from Smalltalk and Forth. It's quite nice in that regard as well. I would point about Smalltalk and Forth as examples of small systems that, while they directly had limited influence, have indirectly changed computing, and which had a bunch of ideas even in the 1980s, which are just becoming mainstream over the last decade.
Lua philosophy, no battery included.
Yeah, Lua is on the no batteries included side. Smalltalk less so, Forth more so even than Lua. Anyone else?
Any questions? Okay, so thank you very much.